All right. Um, this is, again, probably not many people are actually watching this as I'm doing it, which is fine. I'm going to go through this practice test step by step mostly. I'll probably really explain one of each of these problems and then kind of go through the second. But I'll just kind of go through it, and as you have questions, just either email me or put it in the chat, and I'll try and answer them as best I can. Keep in mind, I want to make sure people understand this. Like, this isn't meant to be the only thing that you study. This is just to make sure that you have this along with the practice test to be able to do and kind of check your answers and check your logic and check your work. This isn't meant to be like the only thing that you study. All right. So I'll just go ahead and start with number one. All right. So solve each equation by factoring. There's two equations here. R squared plus 7r plus 12 is equal to 0. And x squared minus 7x plus 10 is equal to 0. Okay, so these are both quadratics. There's a whole bunch of different ways to solve these. I am asking you right now to do this by factoring. And this is specific because the leading coefficient in both of these is just 1. Okay, and when it's like that, it's really, really easy. Okay, you're just asking yourself factors of 12, in this case, that add up to 7. Right, so factors of 12 that add up to 7, that'd be 3 and 4. Right, so if you want to make a factor tree, you could do 6 and 2, but this is equal to 8. You could do 4 and 3, this is equal to 7. Right, you could do 12 and 1, but that's equal to 13. So this is the one we're going to use. All right, so then this will be r plus 3. R plus 4 is equal to 0. And then when you have a product of two things that's equal to 0, one of those two things has to be 0. So either r plus 3 is 0 or r plus 4 is 0. So r is equal to negative 3 and r is equal to negative 4. Same thing for number 2. Number 2, we need factors of 10 that add up to negative 7 this time. Right, so if we do a factor tree, we need factors of 10 that add up to negative 7. So both of our factors are going to be negatives. So we could do negative 10, negative 1, but that's equal to negative 11, negative 5, negative 2, and that equals negative 7. So negative 5 and negative 2 are our factors. So this will be x minus 5, x minus 2, and so x is equal to 5 and x is equal to 2. If you wanted to check this, right, we could plug in 5 or negative 2 into both of these. All right, so let's just do that. If we were checking the second answer, right, we would get 5 squared minus 7 times 5 plus 10, and that should be equal to 0. So 25 minus 35 plus 10 should be 0. 25 plus 10, that's 35. 35 minus 35, that's 0. So that checks out. And you could do the same thing for 2. Just plug it back in and make sure you get 0. Okay, there's a whole bunch of different ways to check these. All right, number 3 and 4 are a little bit harder. We want to solve each equation by factoring just like we did above, but in this case the leading coefficient is not 1. So I'm going to do this off to the side. It's going to give me a little bit more room. All right, so if we're looking at 3n squared minus 13n minus 30, we're going to look at this as area. All right, so we know top left box, that's going to be 3n squared, and this bottom one is going to be negative 30. And these two boxes have to add up to negative 13n. Okay, so we need to put factors in to make that happen. All right, so we're going to find the area of the first box, or rather we have the area of the first box. We're going to get the lengthen the width. Okay, so a factor of this box right here, that's 3n and n. All right, if you multiply 3n times n, you get 3n squared. And then we're just going to try factors of 30 such that these two boxes add up to negative 13. So I'm going to choose let's see. I'll just try stuff. All right. So let's do 5 and 6. So let's do -6, +5. Right, -6 times +5 gives us -30, so that works. N times +5 is 5n. 3n times -6 is -18n. So all of this stuff inside is equal to all this over here. So then 3n plus 5 and n minus 6 are our factors. And then just like up above, we set both of those equal to 0 and self. So n is equal to -5/3, and n is equal to +6. Same thing for the other one. We know 6x squared and -2. This is a little bit harder because 6 isn't prime. So I'm going to do x squared, and I'm going to try 6x. And then we want -2 up here and +1, right? -2 times +1 gives us -2, and x squared plus times 6x squared gives us 6. Yeah, sorry, this should be just x. X times 6x gives us 6x squared. All right, so now when we do this, x times 1 is just x. 6x times -2 is -12x. These two boxes add up to -11x, so those are our factors, right? Everything in these boxes is exactly what we have over here. So then we have x minus 2 times 6x plus 1 is equal to 0. Setting both of these factors equal to 0, we get x is equal to 2, and x is equal to -1/6. Five and 6 factor each completely. So these are going to be using the perfect square binomial or a difference of squares. All right, so I want to just write what that means over here. Perfect square binomial means we are taking something and just multiplying it by itself. Right, we're taking two binomials, multiplying them by itself. All right, so we would get a squared plus 2ab plus b squared. Right, we get that by foiling. Okay, so we're going to get something like that with the perfect square binomial. Okay, a difference of squares means we're multiplying something by its conjugate, which will show up here toward the latter end of the test. But if we FOIL this out, we just get a squared minus b squared. Okay, so these are the two things that we're going to be factoring. All right, so number 5, we have something squared minus something squared, right? So this would be a plus 5 times a minus 5. And this doesn't say to solve, so we're not really worried about it. We're just worried about it factoring. So that's our answer. For number 6, we have something squared, and then we have a middle term. So what we can do is we can check the square root of this thing and the square root of this thing. So that'd be 2b minus 3 times 2b minus 3. And if we FOIL this back out to check, we should get the thing up top. So that'd be 4b squared minus 6b minus another 6b, and then plus 9. So this checks out. So this is our answer. Number 7, solve each equation with the quadratic formula. Simplify completely. All right, so the quadratic formula says that 4ax squared plus bx plus c is equal to 0. X is equal to negative b plus or minus square root of b squared minus 4ac all over 2a. So in this case, a is 11, b is negative 4, and c is negative 20. So then x is negative b plus or minus the square root of negative 4 squared minus 4 times 11 times negative 20. And this is all over 2 times 11, so 22. So if we just simplify this, we get x is equal to 4 plus or minus 16 and then 4 times 11 times 20 so plus 880. All right, keep in mind double negative. Negative times negative is equal to positive, and this is all over 22. So now our goal is to just simplify this. So we get x is equal to 4 plus or minus 896 all over 22. And that's not perfect, so we have a little bit of work to do. But right now this is our answer. So x is equal to 4 plus or minus square root of 896 over 22. So I'm going to do this in different colors so we know what I'm doing. So 896. We need perfect square factors of 896. So if we divide this by 2, we get 448. We can divide this by 2 again. Get 224. We can divide by 2 again. Get 112. Divide by 2 one more time. Get 56. Do another 2. 28. And I know I can do this 4 and 7. Just save a little bit of time. So we can rewrite square root of 896 as the square root. So these are all our factors now. Right, so these are our factors. Rad 2 times rad 2, this is just 2. Rad 2 times 2, that's just 2 again. Rad 4, that's 2. So we would get 2 times 2 times 2. So that's 6. And then rad 2 times rad 7, that's just rad 14. This is all over 22. And then we can simplify even more. I'm going to bring this over here. So can take a 2 out of everything. So this would be 2 plus or minus 3 rad 14 over 11. So that's a lot. It's not really this part though, it's the simplifying, right? So we got to be able to simplify radicals. Next part, factor each grouping or difference of cubes. Okay, so the one with the 4 terms, that's going to be grouping normally, at least for me. Hi, Seamus. I'm reading it, don't worry. So in order to factor these, I'm going to group 2 together. And I'm going to factor out common terms for both of those, right? So the greatest common factor from this first set is x to the 5th. And then we're left with x squared plus 3. And then from the second group, we can factor out a negative 4x. So we get x squared also plus 3. Right, so if each of these are its own term, we have common terms of x squared plus 3, so we can factor that out. And then we're left with x to the 5th minus 4x. And we can actually go further than this. X squared plus 3 can't go anywhere. We can factor out an x from this term. And then we have a difference of squares here. I'm not going to expect you to do this. This would be your answer. But just so people know. This is why that answer is what it is down below. Right, so you have x times x squared plus 3, and then you can factor this as a perfect square. That doesn't look good. We can factor this as a perfect square, right? So that's x squared plus 2, x squared minus 2. And that's why you have a bunch of different terms. So that's like the factoring part. And again, I get that that's a lot. But as long as we know the basic idea how to factor, along with, well, sorry, I'm missing something. This one. First, this isn't the difference of cubes yet. We can factor out an x from both of these things. So we get x to the 6th minus 64. And again, this doesn't look like a difference of squares yet, but this x to the 6th is x cubed squared. And then this would be minus 8 squared. So then this is x times x cubed plus 8, x cubed minus 8. And again, you could go further than this by factoring this with the sum of cubes, but I'm not going to expect you to do that. So then this is your answer. I'm just looking for that first step right now. Find the inverse of each function, right? So we should know that an inverse of f of x, right? So a function g of x is the inverse of a function f of x if f of g of x is equal to g of f of x, which is just equal to x, right? So f of g of x is equal to x and g of f of x is equal to x. I'm only going to require one of these, so you have to check one of those for that. But basically what this means is that the two functions undo one another, right? So if that's the case, then it's an inverse, right? But in order to do that without a second function, what we need to do is we need to invert all of these operations, right? So to do that, right, if we rewrite this as y is equal to 3 over x plus 1, to find the inverse, we swap the variables, right? So now we're going to write x is equal to 3 over y plus 1, and we're going to solve for y. So we would subtract 1 from both sides. So we'd get x minus 1 is equal to 3 over y. I'm going to flip everything, right? So we want y up top. So it's going to be 1 over x minus 1 is equal to y over 3. And then we multiply everything by 3. So y is equal to 3 divided by x minus 1. And that would be our inverse. Right, so we swap the variables and then solve for y. So for number 11, right, if we rewrite this as y is equal to the fifth root of x minus 1 plus 2, we're going to swap x and y. And then we're going to solve for y. So we have to subtract 2. In order to undo a fifth root, we need to take everything to the fifth. So this is going to be x minus 2 to the fifth is equal to y minus 1. And then add 1 to both sides. And this will be our answer. So that's how to find the inverse. Again, you have y is equal to something. All you're doing is you're switching y and x and then solving for y. Number 12 and 13, this is where I'm asking you to check all of this stuff, right? So we want to compose f and g together, and we should get just x or n or whatever variable we're using. Okay, so for number 12, we can compose g and f. So we want to take g of f of n, and that's going to be equal to, right, n plus 2, that's our input, and then minus 2. And this is just equal to n. Therefore, g is the inverse of f. So our answer here is yes. Right, we could check f of g of n. That would just be n minus 2 as our input, and then plus 2, which is just equal to n as well. Right, so they both work. Either one works. For number 13, we're doing the same thing. All right, so we're going to take f of g of x in this case, or g of f of x, doesn't matter. So this is going to be negative, and then our input minus 3. So then we have negative 5 plus 4/3 x minus 3. So this is negative 8 plus 4/3 x. This is not equal to x, therefore no. Therefore these are not inverses of one another, right? F does not undo G, and G does not undo F. Therefore, they're not inverses. Number 14 and 15, solve each equation. Logs not required. All right, so there will be a couple of sections to this. These are where we want to use the one-to-one property. So we want to get, all right, so this is, I'll write this. One-to-one property says that if we have a to the power of b, and that's equal to a to the power of c, this means that b must be equal to c. So we're trying to get number 14 and 15 to look like that. So we need a common base on both sides, where in this case a is our common base. Right, so we look at 81 and 1/9. Those both have a common base of 9. Right, so we can rewrite 81 as a base of 9 as 9 squared. So 81 is 9 squared, and that's the power of negative 3x. 1/9 is 9 to the negative first, and that's the power of negative 2x. So then we have 9 to the power of negative 6x, right? Because if you have a power of a power, you're multiplying, is equal to 9 to the power of 2x. So now we have a common base. So all we have to do is set the exponents equal to one another. So negative 6x is equal to 2x. So then x is equal to 0. Same thing on number 15, right? 3 and 9 have a common base of 3. So the left is going to stay the same. And we can rewrite 9 as 3 squared. So we have a common base of 3. So negative p is equal to 2. So then p is equal to negative 2. And that's our answer. For logs, we want to remind ourselves of the inverse property. Right, and all this is going to say is that logs undo exponentials. And exponentials undo logs. Right, so what this means is if we have a to the power of b, in order to undo this, we would take log base a of both sides. And that would just leave the exponent on the left. Right, in the same way, in order to undo log base a of something, we would take that as an exponent of a, and then we would just be left with b. Right, so that's the inverse property. And that's what we're going to be using on 16 and 17, right? So there's a little bit of algebra involved, right? We have to get 5a by itself. So we would divide both sides by this 5 first. So then we'd have 10 to the power of negative 5a is equal to 22 over 5. And then we have to get rid of that we have to get rid of that base of 10. So we want to take log base 10 of both sides. Right, because what you do to one side, you have to do to the other. And that's going to leave negative 5a. We're just going to keep the right-hand side the same. And then we're going to divide both sides by this negative 5. So then we have a is equal to log base 10, 22 over 5, all divided by negative 5. 17 is the same, right? We need to get negative 2n by itself. So the first thing we got to do is get rid of this negative 5. So we have 19 to the power of negative 2n is equal to 21, right? That's adding 5 to both sides. We want to get rid of the base of 19, so we have to take log base 19. These cancel each other out, so we have negative 2n is equal to log 19 of 21. Then we divide both sides by negative 2 and we get an answer. (18 and 19) and really 20 and 21 and even up to 23 have to do with condensing and expanding logarithms, right? So I'm going to write those down. We have to remember, again, from the thing up above that I have written, if we have log base a of b is equal to c, this is the same thing as saying a to the power of c is b. All right, so that's the definition of what a logarithm is. And from this, we get a couple of different properties, right? And it all comes from properties of exponents. So, right, if we split this up into exponentials and logarithms, right, we know different properties of exponentials, right? So a to the power of b times a to the power of c is a to the power of b plus c. The logarithm version of that is log base a of b plus, make this a little bit smaller, actually that'll work, plus log base a of c is equal to log base a of b times c. And then if we have a quotient, right, a to the power of b over a to the power of c is equal to a to the power of b minus c. This is the same as log base a of b minus log base a of c is equal to log a of b divided by c. And then finally, a to the power of b to the power of c is equal to a to the power of bc. That's the same as log base a of b to the power of c is c log ab. Right, so we're going to be using these rules. I didn't mean to drag that out. We're going to be using these rules to solve these problems. Right, so condense each expression to a single logarithm. We're going to take each of these as their own problem. And we're going to condense it together using this stuff. Right, so 3 log 3 of u, we can rewrite that as log 3 of u cubed. And then we have minus 15 log 3 of v, which is log 3 of v to the 15th. And then we have a difference of logs with the same base. So then we're going to take the quotient of the insides. So we get that. Same thing on number 19. We can simplify both terms, right? So we have log base 6 of a to the 4th. minus log base 6 of b to the 5th. Then we have a difference, so we have log base 6 of a to the 4th over b to the 5th. Going the opposite way, right, so number 20, we would rewrite this as 5 log 2 of 8 squared over 5, which we could then change into 5 log 2 of 8 squared minus log 5 of 5. Which would be 5 times 2 log 2 8 minus log 5 of 5. And this is really what I'm looking for. The answer key puts this in a couple of different ways. So log base 2 of 8, right? 2 to what power is 8? That's 3. So this would be 5 times 2 times 3 minus log base 5 of 5. So 5 to what power gives you 5? Well, that's just 1. So 6 minus 1 is 5. 5 times 5 is 25. That's why that's that answer. Okay, but this is what I'm looking for. Right, if we get here, that's what I want. But the answer key gives you this, which is fine. If you get down to that, that's fine, but I'd be looking for work. Same thing on number 21, right? So this would be 4 ln of x over y to the 5th, which we could rewrite as 4 ln of x minus ln of y to the 5th, which would be 4 ln x minus 5 ln y. And this would be our answer. Number 22 and 23 are kind of putting all this stuff together. So number 21, that's the one-to-one property. It's just using logs instead of exponents. So if we have log base a of b is equal to log base a of c, that means that b is equal to c. All right, so we're going to use that on number 22. So we have log base 11 on the left and log base 11 on the right. So then we can just cancel those. And then solve like we normally would. Number 23 is a little bit trickier because we have to condense the logs, right? So we don't have a common log on the left and a common log on the right. So we have to condense everything on the left and then use different properties in order to solve, right? So we would condense this as log of 5x squared plus 20 in order to get rid of log with no base, right? So I guess if we just have log a, right, there's no base. This is the same thing as log base 10 of a. I'll try and make sure that that's a little bit more obvious, but these two things are the same. Right, so in order to get rid of this, there's a 10 there. So we have to use the inverse property. So we're going to take everything as an exponent of 10. So this is going to be 10 to the power of log base 10 of 5x squared plus 20. And what we do on the one side, we have to do on the other. So this is going to be 10 squared. When we do this, those cancel. And we have 5x squared plus 20 is equal to 100. So then 5x squared, and you could factor this, you could use the quadratic formula, but I'm going to do the easy way. 5x squared is equal to 80. X squared is equal to 40. So then x is rad 40. And again, we have to simplify. So this is rad 4 times rad 10, which is 2 rad 10. So that's our answer. So this stuff, that's like the log stuff. Everything else is quadratics and algebra that we've done before. Uh, 24, 25. This is the stuff that we just tested on. Right, so these are asymptotes and all that. So I'll go through my kind of process. I'm going to factor the top and bottom just to make sure. So this is x times x squared minus 16 over 4x times x minus 3. We could factor the top more into x plus 4x minus 4. But there's not going to be anything we can cancel out, so there's not going to be any holes. Well, there's going to be one hole, but it's going to be x, right? So there's a common x on top and bottom. So we can factor those out. And there's going to be a hole where the thing we factored out is 0. So hole at x equals 0. What's left is like the problem we're going to be kind of going through. Okay, so we have x squared minus 16 up top, and then 4 times, well, I guess 4x minus 12 down bottom. So our vertical is going to be when the denominator is equal to 0. So there's going to be a hole at 0 and a vertical asymptote at 3. And then horizontal, we get by comparing the degrees of the numerator and denominator. The numerator degree n, and I'm going off of this one, doesn't really matter which one, should be the same, is 2, and m, the denominator degree, is 1. So the degree of the numerator is greater than the degree of the denominator, which means there is no horizontal, but that there is a slant. So our slant we get by actually doing this long division. Remembering that I'm going to keep this 0x because that's a placeholder. Right, so 4x into x squared. So what times this gives us this? It's going to be 1/4 x. And if we multiply 1/4 x by everything, we get x squared minus 3x. We are subtracting everything. So we get 3x, and we bring down the negative 16. And then we rinse and repeat. So 4x times what is 3x? So this will be 3/4. And after this, it honestly doesn't matter because everything else will be a remainder. So then this is our slant. So we graph this. So 1/4 x plus 3/4. 3/4 is just under 1. And then we go up 1 over 4. Okay, so that's all like the work. That's all the hard work. And then the rest is just checking. Right, so I'm going to check 0. if we plug this in, we're going to get 0 over negative 12. So that's just 0, right, going off of this. So that's down here. It's down here. So our graph will be below that asymptote, which kind of means it has to be down here or up here. But we can check that too. So we could check f of 4. So we'd get 0. Wait. So it'd be 64 minus 64, which is 0. And what did I do here? Oh, okay. This should have been negative 16 over 16 minus 4, which is 4. So this should be negative 4. Which is still below. I just want to check the answer key though. No, I'm wrong. Okay. So I gotta redo this. All right. So we have a hole at 0. So long x equals 0, we have a hole. All right. So we want to check f of 0, which is going to be 0 squared minus 16 over 4 times 0 minus 12. That's why. Okay, so this is going to be positive 16 over 12, which is 4/3. This is above our slant. So it'll go through like right there, and then there's the hole there. So then our graph is going to look like this, where when it crosses x equals 0, that's where our hole is going to be. So that means then that our other part of the graph is going to look like this. Again, we could check that. We could check f of 4. That is going to be 0 over negative 4, which is still 0, and that's below. So factor out everything, make sure there's no holes. If there is one, just mark it. Find the vertical asymptote, find the horizontal asymptote. If there's no horizontal asymptote, find the slant, and then you're checking to the left and to the right of every vertical. So a little bit confusing because there's a lot going on there. I understand that. Number 25, kind of the same thing. Can't factor the top. We can factor the bottom though, which will make our lives a little bit easier later on. So if we factor the bottom, we get this. That should be +1. So there's nothing we can factor out, so no holes. Okay, vertical asymptote is when the denominator is 0. So that's when this is 0. So x would be equal to 3, or x would be -1. For horizontal, the degree of the numerator is 0. The degree of the denominator is 2. 0 is less than 2, which means that y is equal to 0. It's our horizontal asymptote. So now we check to the left, in between, and to the right. I'll do that over here. So f of 0. Actually, I'll do the left first. So f of negative 2, that's going to be 1 over 4 times negative 2 squared minus 8 times negative 2 minus 12, which is yeah, 1 over 20. That's above 0. So it's above our horizontal. So our answer is going to be up here. Then test to the right. So f of 4. This is still going to be some positive number. So our answer is still going to be above. And then we test in between. Which is below. So our graph is down here. All right, then we get to like slightly less work. 26, 27, 28, and 29 all have to do with rationalizing. All right, so when you have an irrational thing in the denominator, that's not like an acceptable answer, so we got to be able to deal with it. When it's just one thing and it's just an irrational, we just need to multiply by that thing over itself, right? Because we can only ever multiply by 1. So if we do this, we'd get 5 rad 7 plus 5 rad 14 all over just 7. And then this would be our answer. When there are two things, we need to multiply by the conjugate, right? So again, something times its conjugate is just going to be the difference of squares, which is really useful when we're dealing with square roots, right? So we're going to multiply this by negative 10 minus rad 10 over negative 10 minus rad 10. And when we do this, we get negative 30 minus 3 rad 10. That's the top. And then negative 10 times negative 10, that's 100. We could FOIL this out, but again, that difference of squares tell us what we're going to get. And we're going to get minus 10. So we get negative 30 minus 3 rad 10 over 90. And then we could simplify this if we wanted to. So this would be negative 10 minus rad 10 over 30. This would be our answer. Number 28 and 29 are pretty much the same thing, except we have to deal with the square root of 1, negative 1, which is I. And the important thing here to know is that I squared is negative 1. Negative 1. Okay? So what that does is whenever we square something or multiply something I times I, we're going to get negative 1 out. Okay, so this I is just like a radical. Okay, so in number 28, we're going to multiply by I over I, which is going to give us negative 7i, right? That negative is this, over 9i squared, which is the same thing as negative 7i over negative 9. So we get 7i over 9. (29) is just like 27. We have to multiply by the conjugate. So we have to multiply by 1 minus 5i over 1 minus 5i. When we do this, we have to FOIL the top. So we get 1 minus 5i minus 3i plus 15i squared over 1 squared minus 5i squared, which is going to be negative 14 minus 8i over 1 plus 25 so this could be your answer. The answer key is probably going to have something a little bit simpler, so it would probably be, because we can factor out a 2 from both of those. So negative 7 minus 4i over 13. That should be the answer. Yep. Okay. 30 through 33, I'll have to do a trig. Right, so for a right triangle, with an angle theta, the long side, the side opposite the right angle, that's going to be our hypotenuse. We're going to call that C. And then we're going to call the other sides A and B. So we know that A squared plus B squared is equal to C squared. And then sine of theta is opposite over hypotenuse, which is going to be the same thing as A over C in this case. Cosine is adjacent over hypotenuse, which is going to be B over C in this case. And then tangent is going to be opposite over adjacent, which is going to be A over B in this case. And then there are a couple more, but they're just reciprocals of these. So we have cosecant. That's the reciprocal of sine. So that's hypotenuse over opposite, which is C over A. Secant, which is the reciprocal of cosine, which is hypotenuse over adjacent, which is C over B. And then cotangent is going to be adjacent over opposite, which is going to be B over A. Okay, so we have to use all of this to solve those questions. All right, so so number 30, tangent of this triangle. So this is our theta, right? So that means this is the opposite side, and then 12 is the adjacent side. So this is going to be equal to 9 over 12, which is 3 over 4. Secant of theta, we want the hypotenuse over the adjacent side. So that's going to be 25 over 15, which is 5/3. All right, so 25 is our hypotenuse. 15 is the side that's touching theta. That's not the hypotenuse, so that's the adjacent. 32 and 33 are going to require that Pythagorean theorem. So we need sine. So sine of theta is opposite over hypotenuse. Given cosine is 15 over 17. So we know that the adjacent side is 15. We know that the hypotenuse is 17. So we need to find that third side. So we know that the hypotenuse squared is equal to the sum of the squares of the other two sides. I guess this would be A. So then we got to do some math. $17 squared is 289. $15 squared is 225. So 289 minus 225 is 64. So then A is 8. So then sine of theta is going to be equal to 8 over 17. All right, again, we're given the hypotenuse and the adjacent sides, and we have to find the opposite side. So now we want to find tangent of theta, which is opposite over adjacent, given the secant, which is hypotenuse over adjacent, is rad 2 over 1. Okay, so we have a triangle, which I probably should have done this on the last problem. We have a right triangle. We know that the hypotenuse is rad 2. Given some side, we know that the adjacent side is 1. So we need to solve for this side. Okay, so we would have 1 squared plus the other side squared is equal to rad 2 squared. So 1 plus b squared is equal to 2. So b squared is 1. So then b is 1. So this b is just 1 again. So then the tangent of theta is going to be the opposite side, which is the b, which we just found, over the adjacent side, which we were given. And then we have our answer. So that's most of the test. There's like 2 more problems that have to do with parent functions. Okay. So the parent functions I'm expecting to know are linear, so that's y equals x. I'm not going to draw these because I did that in class. So we have g of x is equal to negative absolute value of x minus 1. So absolute value, that's like the corner function. It kind of looks like a corner. It's just something that looks like this. We have a negative, so we're multiplying by a negative. That flips it upside down. And then we have a minus 1 on the outside, which shifts it down 1. So we have an absolute value function flipped upside down, shifted down 1. So that's going to look like this. Okay. Number 2, we're dealing with a square function, so a quadratic. We are multiplying it by 1/3, which basically is going to make it wider. And then we're shifting it right 1. So our function, right, so we know our vertex is going to be right here. And then we're not going up quadratically, we're going quadratic and then divide by 3, right? So if we go over 2, we should go up 4, but we're going 1/3 of that. So 4/3, which is like right here. And I would label a couple of points, right? It's the vertex. This is -1, 0. When we plug in 3, right, so this would be g of 3. That'd be 1/3 3 minus 1 squared. So this is 3, 4/3. And we're going to get the same thing, so this would be -1, 4/3. Okay, but what I'm looking for is you being able to know what the parent function actually looks like, and then knowing how to shift it and make it wider or narrower. Okay, and the rules for that, I wrote down that in class, but if you're adding something on the outside, this is up and down. If we're adding or subtracting something on the inside, that's left or right. Keeping in mind that it's always the opposite of what you think, right? So if we do minus c, we're actually going right c units. If we're adding c, we're actually going left c units. If we multiply by a negative on the outside, that flips it upside down. And if we multiply by a negative on the inside, that flips it left to right. And then we have these two different cases. If we multiply by something on the outside, this is going to be steeper if c is greater than 1, and wider if c is less than 1. And then if we multiply by something on the inside, this is going to be steeper I have to think about this. This is going to be steeper if c is greater than 1, and wider if c is less than 1. They're just called different things. All right, so there's horizontal stretches and vertical stretches, but what I have up on here is correct. All right, so this is the entire test. This is in OneNote. It's in the content library. Okay, and all the answers are here too. That's what I'm scrolling through right now. But yeah, this is everything. I hope this helps a little bit. Again, this isn't meant to be like the only way you're studying. There's a whole bunch of different review problems in on campus. So use those, and I'll be available up until your exam. Okay. Again, if you just want to scroll through the notes and not watch the entire video, this is here for you. If you want to watch the video and me explaining it, that's there for you. But that is all I have for now. All right. So if you have questions about this, please email me or come in before school or after an exam. I'll be available. All right. So I'm going to stop this now, and this will be available within the next couple of hours for you to watch whenever. All right. So thank you. Good luck on your exams, and I will see you later.